Projection on a line. Let's do some problem solving. First one, find the projection of AB on the line CD, where A is equal to 1, 2, 3, B is equal to minus 1, 0, 2, C is equal to 1, 4, 2, and D is equal to 2, 0, minus 1. Okay. Now let's focus on uh, direction ratio of AB. So direction ratio is what? X2 minus x1, y2 minus y1. So here what will it be? Minus 1, minus 1. So minus 1, minus 1. Okay. 0 minus 2. 2 minus 3. Which would be minus 2, minus 2, minus 1. Yes. Similarly, direction ratios of CD would be what? Again, 2 minus 1. 2 minus 1, 0 minus 4, and minus 1 minus 2. So this would be 1 minus 4 minus 3. So we have got the direction ratios of AB and CD. Now the direction cosines of CD would be, remember, we take each one of these and divide it by the square root of the squares of this. Square root of the sum of the squares. And we know sum of the squares will always be positive. So, squares will always be positive. So we can directly say 1 plus 16 plus 9. Which comes to what? 26. So let's directly write 26. 26 minus 4 by 26 minus 3 by root 26. So here this is L, this is M, this is N. L, M, N are the cosines of direction cosines of CD. So now projection of AB on to CD would be the direction cosine times the direction ratio of AB. So let me directly write it. 1 by root 26 times minus 2. Okay. Then plus M is again minus 4 by root 26 times minus, what is it? Minus 2 again. Plus minus 3 by root 26 times minus 1. Okay. So let's simplify this now. Minus 2 by root 26 minus into minus plus plus 8 by root 26 minus into minus plus 3 by root 26. Root 26 minus 2 plus 8, or 8 plus 3, 11 minus 2 is 9. So that is the projection of AB onto CD. Okay, let's do the second one. Show that line AB is perpendicular to CD, where A is equal to 2, 6 minus 2, B is equal to 5, 8, 0, C is equal to 2, 3 minus 1, and D is equal to 0, 4, 1. Now direction ratios of CD are 0 minus 2, 4 minus 3, and 1 minus 1. 1 minus minus 1, so plus 1. So this becomes minus 2, 1, 2, right? Now similarly, direction cosines of CD are L is equal to minus 2 by minus 2 square plus 1 square plus 2 square, the whole under root. Yes. So minus 2 square is 4. 4 plus 1. 4, 4, 8 plus 1, 9. Square root of 9 is 3. Okay. M is equal to 1 by 3. N is equal to 2 by 3. Okay. So we have got the direction ratio, direction cosines of CD. So the projection of AB on CD would be equal to minus 2 by 3 times the direction ratio of AB, which we have not done it. So let's mentally do it. 5 minus 2 is 3 plus 1 by 3 into 8 minus 6, 2 plus 2 by 3 times 0 minus minus 2, that is 2. So this comes to, these two get cancelled, minus 2 plus 2 by 3 plus 4 by 3, which is equal to, if we had not cancelled it, it would have been better than the denominators would have been same. Anyhow, minus 6 plus 2 plus 4 by 3, which is 4 plus 2 is 6, minus 6 is 0. Now what does this 0 mean? Remember, we are talking of two lines, right? If there is some angle, there is an angle, the projection would be this, right? So this would be the projection of this. Clear? So, which means as this angle keeps increasing, what will happen? Right? This will keep reducing, right? And when will it become 0? When the angle is 90 degree. So therefore, what we have proved is that AB is perpendicular to CD. So basically, the shadow of AB on CD disappears. See, just like our own shadow, it basically disappears during daytime when the sun is exactly over it. Okay, so it is perpendicular when the sun is perpendicular to the surface on which we are standing. Anyhow, okay, third one, projection of line segment AB on CD. Now, A is given as 3, 4, 5. B is given as 4, 6, 3. C is given as minus 1, 2, 4. And D is given as 1, 0, 5. Okay. Now here we have to find the projection. So let's find the DRs, that is direction ratios of CD, right? So 1 minus minus 1. So 1 plus 1. Similarly, 0 minus 2, 5 minus 4, which is 2 minus 2, 1. Now, direction cosines of CD. This would be what? This would be 2 divided by the magnitude of CD. That is 2 square plus 2 square plus 1, that is 9. Square root of 9, which we can write it as 3. Okay, minus 2 by 3. 1 by 3. So now projection of AB on CD would be equal to, take this direction cosine of CD and multiply it with the direction ratio of AB. The direction ratio would be what? 4 minus 3, 1 plus, now minus is there, so let's put minus 2 by 3 times 6 minus 4. 6 minus 4 is 2 plus 1 by 3 times 3 minus 5, that is minus 2. So 2 by 3 minus 4 by 3 minus 2 by 3. So this and this gets cancelled. We are left with minus 4 by 3. And we basically ignore the minus sign. Because when we talk of projection, we are talking of the length. So length can't be negative. So therefore, projection is equal to 4 by 3 numerically. Okay, fourth one. So that the line segment joining A1, 2, 3 and B3, 5, 7. This is 3 has no projection on the line with direction ratios of 1, 2, -2. So basically what is happening here is the same type of problem is being reworded, right? So when will a line have no projection? When the angle is 90°, right? So basically what we have to do is we have to prove that these two lines are going to be AB and the other line are going to be perpendicular to each other. Okay, so let's do that. Direction ratios of the line, let's say this is the L, of L is equal to 1, 2, -2. Now direction cosines of L would be 1 by square root of the squares of these, sum of the squares. So 1 square plus 2 square, so 1 plus 4 plus 4, that is 9. Square root of 9 is 3. 2 by 3 minus 2 by 3, right? So now the projection of AB on L is equal to the direction cosine of L times the direction ratio of AB, right? So direction ratio of AB will be 3 minus 1. So 3 minus 1. It's better to write in one step, write this 3 minus 1 so that, to trace back any mistakes that you might have made, it becomes easier. 5 minus 2. Okay. So plus 2 by 3, 5 minus 2. Okay. Plus, now minus 2 by 3 is there. So minus 2 by 3 times 7 minus 3. 7 minus 3. So this becomes 2 by 3. 5 minus 2 is 3. 3 to 6 by 3. Minus 7 minus 3 is 4. 4 to 8 by 3. So here 3, and on top what happens? 2 minus 6 minus 8, and this becomes, actually this will not be minus, this will be plus. 5 minus 2 is 3. 3 to 6 is 6 plus 6. So this is plus. So here what happens? 6 plus 2, 8 minus 8 is 0. So what does this imply? It implies that there is no projection of AB on L. Okay. Fifth one, the projection of a line on the axis are 3, 4, 12. Find the length and direction cosines of the line. Okay, pretty straightforward, right? This is nothing but the coordinates of a point. Projection of a line on the axis means what? When you drop a perpendicular from this point, in the x direction it will be 3, in the y direction it will be 4, in the z direction it will be 12. So the length of the line is pretty straightforward. Pythagoras theorem in 3 dimension. Length of the line is square root of 3 square plus 4 square plus 12 square, which is 9 plus 16 plus 144, which is square root of 169, which is 13. So the length of the line is 13. Now the direction cosines, DCs, are again pretty straightforward. 3 divided by 3 by 13, 4 by 13. 12 by, now the next question is sixth one. Same like before, right? If the coordinates are different, 3, 4, 12, instead of that, if it is anything else, just do it accordingly. So let's take another type of question. A line segment has projection 4, 3, C on the coordinate axis. If the length of the line segment is square root of 29, find, again pretty straightforward, length of line is equal to square root of 4 square plus 3 square plus c square is equal to, what will it be? Length is given as square root of 29. Now if we square both the sides, square, then what happens? We get 16 plus 9 plus c square is equal to 29. This is 25. So c square is equal to 29 minus 25, which implies c square is equal to 4 and c is equal to, and I'm sure you know that ideally it should be written as plus or minus 2. But since we are talking of lengths, writing minus doesn't matter. So we basically ignore the minus sign. So C is equal to 2. So that is projection of a line on another line. Just as a brief summary, let's say we have a line like this and a line like this, right? Let me make it smaller. Let's say we have two lines, correct? Okay. So what we have to do is drop a perpendicular. Let's say this is A, B, and C. AB on BC. Projection would be what? AB. So from A, drop a perpendicular. So this is the projection of, so P1 is projection of AB on BC. Now, if we have to do it for BC on AB, so BC on AB. So what happens? Again, from C, drop a perpendicular. So this has to be, so here, this would be the projection. So let us say this is P2. So P2 is projection of BC on AB, right? Of course, if you have a 90-degree angle between these two, then it will drop. So there will not be any shadow. So the projection would be 0. Similarly, if you drop this, so let's say this is A, B, C. AB on BC is 0, BC on AB is 0 if the angle is 90 degrees. Okay, I think that's enough. Bye for now.